while writing only, you have already seen. So here in the right side, while you have a chat box, no, that you can include which question you felt it's quite required revision like that. So you can put a question over there. So I will go through that. Anyway, I'll also put the assignment question here. And anything to discuss, any questions to be required, so we'll do it. Okay, so let's questions one by one. All revision, that's all. Okay, so those who have already understood, fine. So I'm just presenting the assignment questions here. Just a small revision, that's all. So I never go in depth. How much time permits, within the permitted time, few things. Okay, that's what I felt. Because probably today uh, we'll take some questions with some small revision. Fine with it. Okay. Hope you got your. Info I have. So here, connection between processor, memory, function of each component in the connection. Okay. So while writing this question, you have to write the neat diagram. Okay. So let me take some assignment. Those are already submitted. So let me take that and I'll just show it what is required. Okay. Okay. Some student has done very well. So let me take. Okay. Even Purva is written. Lavanya is written. Okay. Many were written. No. Okay. Let me take any one students disclosed. Okay. Here we are able to see one diagram. Okay. So okay. When you take this. Okay. See the question first. See the question. So don't want to disclose the name of the student. Draw the connection between processor and memory. Okay, and mention the function of each component. Okay, that's the important thing. So memory is this and processor is this. Okay, you have to provide a proper link. So what is duplex link? That means what? From memory, the data will be transmitted to processor, and from processor, the memory will be transmitted to memory. Okay, so this is a two-way transmission. It's one way means only one line. Okay, so only from a control, see control signal from only from here to here. So like that. So control signal was bidirectional. You can send the data from here to here or from here to here. That's important. And you have to represent the registers available. What is MAR? What is PC? What is IR? What is MDR? Control. What is control unit? And what is ALU unit? Okay, all things you have to explain. So probably already program counter means uh, it's a register which holds the address of the next instruction which I will execute, which the processor will execute. Okay, so that about program counter. So if you see this PC, okay, so just it will it's a register which hold the address of next instruction which we will execute, which the processor will execute. That's about PC. I think MAR is memory access register. So memory access register means memory address register. So I want to access some data from memories here. I want some data from memory means okay. What I required actually, obviously I require uh, the data from the memory I require means so I required the address, right? So that's why this register I used to as a space where I kept the address of the data. MDR means the data I will access from memory that I'll keep it in the register known as memory data register. And we have instruction register. So this register is use it for what? So I want to execute one instruction means that instruction will be stored inside the processor. So inside processor where it will where it is available in IR. Okay. So, and even control unit. What is control unit? So, what I should, whether I should read or write down, read from memory, write to memory. So, like that, I want some proper, the control signals I require. Okay, so that's what we are control. And ALU we have arithmetic logic unit. So this is where the real performance will execute. The real addition or subtraction, any arithmetic operation. Okay, so inside the processor, whatever you want to do, arithmetic operations, so everything will be done in the ALU. So you have to explain each and everything um, in detail. Okay, functions of each component. Okay, so that's important. You have to explain the diagram. So and while writing, so see, suppose memory, something like this they have written. No? So what I required is you have to take the diagram, explain properly. So what you should do is where is the diagram is connected to your answer. You have to solve, right. So as shown in the above diagram. So we have a diagram. Okay, with that diagram inside that we have a components. So you have to explain in that way. So here it is nowhere concerned with diagram to explain. That should not happen. Okay. And even in general purpose registers we have the why I required registers. Okay, so I want to put some variable. Okay, variable which I utilize it, which I used to keep the data inside that registers so that processor will access it easily. Okay, that's the main intention. So I hope that's about first question. Basic operational concepts means you have to explain the concepts. Okay. So which concept one instruction you have to take. Add location A comma or not. So by taking this, you have to add two operand. So first operand is in location A. Second operand is in R naught. Okay. You're in there. You're there in the track. Everybody? Yes, yes. Yes or no? You're there. Yes, right? Yeah, you're getting to what I'm doing. I'm just doing a, you know, uh, yeah, yeah, a small revision. Okay, a small, not very. So those who have, missed any classes, uh, anything you missed, you may get it. Okay, that's all. I hope the students are there inside the classroom. They are hearing my words. Okay. So like this, you have to take this example, okay? Add location A, comma R naught. Now how to access data from location A? See, your data available inside location A. Now second operand data is available inside your register, okay? So you have to see from location A means, see the above diagram. Location A means what I should do? Location A means first I should go to MAR. From MAR, okay, I will get the location, okay, location address. Then I will go to memory. From memory, the data will be send it to MDR. ಇದ್ರೆ ಕೊಡಿ ಸ್ವಲ್ಪ ಇದೆ ಆಲ್ರೆಡಿ ಇದೆ ಸ್ವಲ್ಪ ಇದಕ್ಕೆ ಸ್ವಲ್ಪ ಬಿಸ್ತೀರ ಹಾಕ್ಬಿಡಿ ಚೆಂದ ತಗೊಂಡ್ಬಿಡಿ ಇದಕ್ಕೆ ಹಾಕ್ಬಿಡಿ ಓಕೆಪಾ ಸೊ MDR we have MDR. So that data will be that location A data will be copied in MDR. Now from MDR, I will received. Okay, so the ALU will receive, and it will take the first operand. Next operand is in register R naught. Okay, so for register R naught, no need to go for memory. Why? Because it was already there in register. Okay, so now from register, some R naught, you have your second operand, right? So it will access the second operand and it will do the addition operation. Okay, so that thing you have to explain. Some 6 to 7 points are there. That points you have to explain. Okay, now, so like this here is written, I think, see. Like this, you have to explain the steps. There's some 6 to 7 steps are there, I felt. Okay, that you have to explain. Now go to second one, second assignment question. It is here only it is uh, Big Indian and Little Indian. Okay, so this is the concept. So it is Big Indian and Little Indian. It's very important. See, in Big Indian, what I will do, it's very simple. So this is least significant bit. This is most significant bit. Okay. So least significant bit. Okay. So will be stored in the rightmost side, rightmost location. Okay. The you can make out here if you want. You can see here that small explanation is here. Big Indian is used. The lower byte addresses are used in the most significant byte. Okay, lower byte addresses are used for most significant byte. Okay, so most significant bytes data will be copied in the lower byte address. Okay, so lower byte addresses means this one. See, this is 0. Okay, so 0 will be the location where I am going to store. Okay, see, this is, if you want, you are able to see this. I think this is the location. So this is where your uh, least address bytes. That means 0 is your least address, right? Least address means 0. Okay, in that you are going to store the most significant byte data. That's all. Okay, so it is Ulta in Little Indian. In Little Indian, what I will do, the least address. This is least, no? 0 is the least address. So in this least address location, least significant byte I'll store. Least significant byte I will store it in least significant address. That is in Little Indian. Uh, Okay, so this is lower address. 0 is a lower address. This lower address will store not least significant byte. Most significant byte will be stored in the Big Indian. Okay, a little bit. If you want, I'll just pronounce one more time. Little Indian, I'll tell you first. It's quite simple. Least address, see, least address location, okay, or least byte address will store the least significant bit of data or byte of data. Okay, here least. Here it is least byte address will be used to store the most significant byte of data. That's all. Okay, so that's about least significant bit that you have to represent in the diagram properly. Okay, both diagrams. And you have address space, fetch and store. See, address space means what? So as this diagram says, see this diagram, this is the address space. So this is the address space where I am going to store my data. Alright, okay. So address space means what? So I have a data location in the memory. Okay, so inside this memory, I can keep my data. So while I'm keeping the data, how can I access that data? I can access that data by using the location address. This is what locations. See, 0th location, first location, second location, third location. Okay, this is what address space. Inside this space, you can keep your data. After you're keeping the data, how can you access the data? Using the address. Okay, that's all. Fetch and store. Fetch means what? Fetch means access the data. See, fetch means I will access the data from this memory location. Okay, so by using the address, I will access the data. I will read the data from the memory. That is fetch. Write means what? Store means what? Writing the data to the memory. So we have a space here. I will write. I will write the data to the memory. Okay, that is what. Uh, that is what writing, uh, fetching, and storing. Okay. Now we have straight line sequencing and branching. See, straight line sequencing and branching is quite simple. Straight line sequencing means what? We have instructions. We have n number of instructions in the program. Suppose I'll take this one. Written one. See, this is the program also should take straight line sequencing, right? Okay. Now this is straight line sequencing. Suppose c is equal to a plus b. For this, I want to write the program. How to write the program? I'll write one, see, line by line. First line is what? Take the data from the memory. So move a comma r naught. Okay. So I'll keep the data from a to r naught. I'll move from a to r naught. Next, either you can move b to r naught or you directly add b comma r naught, because anyway r naught is having a data. Now you directly add b comma r naught so that you will get the result of a and b. Okay, that data I will send it to r naught. Sorry, that data will be, I will send it to c. Okay, now so like this I am going to, and even while executing, first this line move a comma r naught will execute. Next to a b comma r naught will execute. Next to move r naught comma c will execute. This is known as sequential instruction execution. Okay, sequentially one by one instruction will execute. Hope you are clear. Okay, when it is another question, so we have another question, right? It is what? Branching. So branching is quite different. Branching means what? See, I will execute one instruction. After that, I can branch to some other instruction. You know, right? Looping, right? Right. Which is the best example for branching? Obviously, it is for loop. If conditional statement. If that condition is true, then I will go to the statements inside if. Otherwise, I will go to else, isn't it? Okay, are you agree? Okay, so in that manner, here also, so here you have to explain one program to be taken, and okay, and you have to execute. Okay, so let me reduce this. Okay, still more I'll reduce so that I am able to see complete program. So what's the main thing is, suppose you are going to add some n number of data. You're going to add some n number of data. So that's why you are going to take next number and you have to add, and you have to add each and every number. First I'll take n1, next I'll take n2, next I'll take n3, next I'll take n4, like that. Okay, so how to add that numbers? Okay, so where there is one condition, so branch r2 is greater than 0. That means what? R2 is nothing but some n. You have kept your I think that program you have to explain. One program is there actually, one example program is there. That program you have to explain. This is fine actually. So whatever she has written is fine. Okay. Okay, I think it was same actually. Yeah. So R2, what is R2? R2 is nothing but n number. And R2 is nothing but n numbers. Okay, n is nothing but 10 numbers. Suppose 10 numbers. So what I should do? So I'm just going to check each and every time whether my R2 is greater than 0 or not. So first n is equal to 10. So I will take 10th number and I'll add it. Okay. Next I'll take ninth element. Next I'll take eighth element. Next I'll take, each time I'm going to check the condition whether my R2 is greater than 0. Whenever R2 is 0, what's the meaning? I've added all the elements. First I'll take 10th, next I'll take ninth, next I'll take 8th, next I'll take 7th, like that. So when all the elements I've already added, so obviously what you will get, you are going to get the final result. Okay, when r naught is equal to this r2 is equal to 0 means I've taken all the elements, all n elements I've taken and I've added. So by that time you can stop your execution. That is why you have to check the condition whether my r2 is greater than 0 or not. Okay, yeah, this is the program, correct program. Fine. Next we have third question. So directly I'll come to the question directly here. So basic equation, that is performance equation. So we have the t formula here. T is equal to n into s divided by r. Okay. Yeah. I want to see how many are you. You're there in the class. Just type yes, ma'am, present anta. Noda. Simply I'm teaching, or people are there inside the classroom. Yes, sir. Yes, you're there. You're getting my words. Revision. Okay, it's quite easy. While you're, you can easily keep track. That's what my intention. Okay, people are there. Still, I saw. Ah, okay, very good. Okay, I think you're hearing my words. Okay, it's good now because if students are there, if I'm doing the revision, that's well and good. Without students, I can't. It's really waste of time. Revision. Just a small revision, okay? Small revision. You can now while you study, no, you feel very comfortable. You can study well. See now T is equal to N into S divided by R. Okay. You know what is T? T is nothing but what? The time taken by the processor to execute the instructions. I hope you are clear. So how much time the processor will take to execute an instructions? For example, I will give you 10 instructions. You can have 10 questions. Assume I will give you 10 questions. Okay, pa, you people, uh, okay, all my students, please write 10 questions. I'll give you. What I'll do? Okay, after 1 hour, you just give me the answer. What happens? Some people will, the people studied well. They will take, within 1 hour, they will complete all 10 questions. Okay, they will write fast. They have, write up was very fast and they were already studied. Okay, so then obviously it is, they will give the answer faster and they will write within 1 hour. The people on those who have not studied and who are not able to write fast, what happens? Obviously, they used to give, out of 10, they'll write 8. Some people will write 5. Some people will write 7. Okay, so that will happen. Now, so based on that, we have to require the performance of my processor. That is how, using the formula T is equal to N into S divided by R. It's very simple. So here N is nothing but number of instructions. You can name guest question. How many questions I've given? So here, how many instructions I've given to processor? 1,000. Assume 10,000. 1,000 instructions. So N is equal to 1,000. Okay. See, yes, sir. S is nothing but, I'll give you one best example. Now, out of 10 questions, some questions are, very simple. It is take only 10 lines. Suppose, out of 10 questions, 8 questions are very lengthy. 2 questions are very, less, lines. It requires 5 lines of answer. That's all. So, anyway, whatever it is less line. The very few number of words are required for answer, whatever it is. But overall, I require the overall average is how much. That's what I require. Okay, so what I'll do? Okay, first question 10 lines, second question 10 lines, third question 10 lines. For all questions are 10 lines. Okay, eighth and ninth question 50 lines. Oh, sorry, 5 lines. What I'll do? I'll add. Okay, 80 plus 5 plus 5, 10. 90 divided by 10 I will do. Hope you are clear. That's what that's what the S indicates. Okay, so S indicates means the average number of basic steps required to execute one machine instruction. Okay, so what was my calculation? 90 divided by 10 means what? So it was 1 point, right? So 1.5 like that. Question requires, suppose 10 minutes means. So by this I can say, okay, 10.5 is the average time, like that. Okay, average, overall average time required by one instruction to execute. Because see, 60 minutes, 60 questions, 60 minutes means one question is 1 second. Alvapa, isn't it? 60 minutes, 60 question means 1 minute, one question. But sometimes what happens, one question may take difficult question will take 1 minute, more than 1 minute. Easy question will take less than 1 minute. So average I will do. Okay, out of 60 question, out of 60 minutes, average will be, it may be very 50 minutes. Why? Because if many questions are easy means average may be 50 minutes. By 50 minutes only, you can complete all. So one question may take less than 1 minute. How it is possible? How to calculate that? That is done by yes. Okay. Average time taken by one instruction. That is yes. Okay, now R is nothing but this is the the capacity of the processor. In your class, out of 90 students, some people are very good high Q, some people are very weak. In the sense they'll grab the. Uh, so some students will As soon as the faculty will teach, they will get the concept completely. Some people will not able to receive complete concept. What they require, they want to study one more time, isn't it like that? This is the R is nothing but processor capacity. So in 1 second it will execute 10 instructions. In 1 second it will execute 5 instructions. That's the capacity of the processor. Okay, so I will give the capacity of the processor. I will gives the number of instruction. The average time taken will also I'll give you. Then TV you can calculate easily by applying the formula. It's very simple. You can go to next question. Yeah, C is equal to A plus B. So let me see the question first. C is equal to A plus B. So you have to give that in three address instruction, two address and one address. It's very simple. In class also I've done. Three address means very simple. See, three address means three operand. So directly I can give A plus B, A, B, C at a time I can take because three address instruction. I can give operands, okay, three operands. So because three address no, so I will able to get the data of first address A, second address B, third address C. So I can add directly by executing the instruction. Add A comma B comma C. Two address means what? You can't give all the operands at the same time. You can take only two address. Okay, that is why first I will take out of A plus B. What I will do, I'll take first A, I'll add with R naught. Then I'll take B, I'll add with R naught. Why R naught I am taking here? Because anyway, see here, in this one you just see A data is already available in R naught, so just add A and B. Okay, then store the data in C. That's all, very simple. One address instruction means only one operand you can access at a time. So here, see, right side it was by default accumulator. Even though I have not written anything, by default it is accumulator. That you should know. Okay. So load A to that accumulator. Then from that accumulator, here also the same. Here also accumulator will available by default. So B will be added with the accumulator. Okay. Now it's by default B with data inside the accumulator is what? A. So B with A I have added. Now last one. Okay, store. See here the accumulator comes here. Illenaguthe add and load accumulator is available here. Okay, right side. But here in the store instruction, the accumulator will exist not here. It will exist here by default. It's something like store the data from accumulator to C. That's all. Just you should remember. Okay, it's a very important concept. Oh, now we have. Sir, already update ಮಾಡಿದೀನಿ ನಾನು ನಿನ್ನೆನೆ. ಸ್ಕ್ರೀನ್ ಆದ್ರೆ ನಮ್ಮ ಮೊಬೈಲಲ್ಲಿ ಮಾಡಿದ್ರೆ ಅದು ಸೇವೇ ಆಗಲ್ಲ. ಓಕೆ, ಒಂದ್ ಸೆಕೆಂಡ್ ಅಪ್ಪ, 1 minute. Just one class taken report I'll upload. I'll come. One minute, less than 1 minute. Okay. Okay. Okay, sorry for the interrupt. So we'll go to the uh, what I did. Okay, 3A over, no, 3B over, right? See, if I'm fast, you just put a just give an information, ma'am. That question repeat one more time, like that. Okay. So if you want to just uh, put a question there, if I'm fast, you can tell me. Otherwise, okay. Bus in a system and out write the associated diagram to single bus structure. Because I want to cover all the 12 questions. That's why I may be quite fast. It's very simple. So what you are supposed to explain is you have to take, you know, for my bus, I can connect n number of devices. Okay. So what could be the devices? Input device, output device, memory. Okay. So like that, I'm able to connect n number of devices via a single bus. Okay. So we have to take this one diagram and you have to explain. That's all. I think it was quite simple. You can easily explain. Okay. Hope so. Okay. Isn't it? Next, we'll go to the fourth question. See, fourth question is what? You are supposed to write the program for this expression a into b plus c into d. Okay, for for this one simple expression, you have to write the program. Okay, and they've also given you can do the operation. What operation? Load, store, multiply, and add. Okay, using this instruction, you can write the program and you can use accumulator here. Okay, so if you use that program, you are able to, using that question, you can write the program like this. Okay, it's very simple program. So first I will load the A data. Next I'll multiply with load A. See, by default, what's your right side? It's by default accumulator. Load A to accumulator. So now access the data from the accumulator and multiply with B. Okay. So now I've completed A into B. This got over. Next, what I will do, I'll keep this A into B, resultant in one separate variable, separate, location. That's why store X. So they've used some store X. In X, I have A into B. Okay. Now what I will do, I will take C and D and I'll multiply. Later, I'll add that data with my X. Okay, now. So load C, then multiply with the D. Next, D. So after you multiply C into D, your data is available in accumulator by default. Okay, now what I will do, accumulator data I will add with X because X is having A into B, C into D. Sorry, please listen here. X is having A into B data, and accumulator is having C into D data. Okay, AB data available in X, C into D data is available in accumulator. Okay, so both I will add it. Oh, I need to add, just add X. If you give X, by default in right side it was accumulator. So add both and store the result in some variable. The same variable is X. So store it in some X. Okay, so final resultant, the accumulator data is consisting of A into B plus C into D. Data I will keep inside the X. Okay. Uh, now, okay, this is the example. We have completed this. We'll go to fourth one. So if you go to fourth one, if you go to fourth B, it was spec rating. See, spec rating is very simple. What is a spec rating? See, I will give you one standard system. Okay, now standard. For example, what I will say. So this is the by this 2020, the processor speed should be 1 megahertz, 10 gigahertz per second. That's the capacity of the processor in 2020 systems. Suppose I will say like that. Next, whatever the system they will develop, new systems, whatever they develop now, they'll always compare with my given standard system. Okay, like that, we are going to check the performance. Okay, so for that purpose, what is spec rating? So running time on the reference system divided by running time of the under test. Okay, suppose you're testing the capacity of the system is suppose the reference system capacity is 50 and your system capacity is 100 it will execute 100 instructions per second, but reference system is only 50 instructions it will execute per second. So now how much the say, testing your new system is faster than the existing system. That is nothing but 50 by 100. 50 by 100 is what? 1 by 2. That means 2 times more than the capacity of the standard system or a reference system. So that is what uh, spec rating. And here example also they have given, and this also you have to include. Okay. So standard performance evaluation computers. Okay. So I think by that we can complete my spec rating concept. Then fourth C is one example problem, right? So I think this is the problem we have provided. So we have given 1,000 instructions. So and this is okay. N is equal to 1,000, and we have given even S also. S information is also available here, and this is R. This information is S. This is R. This is N. So easily you can calculate the T. So that's what we have done. T is equal to N into S divided by R. 1,000 into, okay. So out of 1,000 instructions, 25% of the instructions are 4 cycles, and 40% of the 35% of the instructions require 3 cycles, and 40% of the instructions require 5 cycles. Okay, divided by R. R is nothing but 1 gigahertz. Okay, so you will get 4.05 microsecond. So to execute one instruction, to execute 1,000 instruction, the total time taken by the processor is how much? 4.05 microsecond. Fifth question is you have to explain all the addressing modes. Okay, so that is a standard question. You can expect even in final exam also. So all the addressing modes you have to explain. So first is here immediate. So immediate mode. What is immediate mode? So operand is the data of the operand is available in the instruction directly. Example is hash 200. Register mode means your operands of data available in registers R1, R2. Okay, that is register mode. Absolute mode means what? Your operand not available in register or not in the instruction directly. It's available in the memory location. Which memory location? Location A or location B. That is absolute mode. Indirect mode means what? It's like a pointer. It never give you the direct memory location address like location A, location B. It will give you go to this space, go to this location. Inside that location you have address. Go to that address, you have the data. Okay, that is available here inside R. If you go to R1, you have some data inside R1. That data is there, no, that will give you the address of that, that operand. So here operand address is not available in R1. Okay, address of the data available in R1. That is what indirect. ಈಗ ನಿಮಗೆ ಗೊತ್ತಿರಲ್ಲ what is pointer? Pointer will hold the address of another instruction, isn't it? That is why. So here effective address is nothing but see you can differentiate it. Like this small bracket within R1 is enclosed within R1 means it is like it's a pointer. Okay. So here go to address, so address of this operand where it is available. Go to R1, you go to R1, inside this you have some data that you have to access. Plus 4 ಏನಕ್ಕೆ ಬರ್ತಿದ್ದೀರಾ? +4 ಇಲ್ಲ ಬರಲ್ಲ ಇಲ್ಲಿ. ಯಾಕೆ +4 ಬರ್ತಿದ್ದೀರಾ ಗೊತ್ತಾಗ್ತಿಲ್ಲ. Okay, ಬರಲ್ಲ +4 won't come. Index mode. Index mode means what? X of R0, R1. Along with R1, okay, content of R1, even you have to add the X. Okay, then you will get the address of the first operand. That is index mode. Next is base with index mode. Okay, so base with index mode means two register R1 plus R2. Content of R1, content of R2 will give you the address of the operand. That is base with index. Okay, with offset means R1 plus R2, content of R1 plus content of R2 plus X will give you the address. ಇವ್ರು ಪ್ಲಸ್ 5 ಏನಕ್ಕೆ ಬರ್ತಿದ್ದಾರೆ ಗೊತ್ತಾಗ್ತಾ ಇಲ್ಲ. ತಪ್ಪಿದೆ ನೋಡಿ, ಭಾನುಪ್ರಿಯ ಅಲ್ವಾ ಇವರು? ನೋಡಿಪ್ಪ, ಚೆಕ್ ಮಾಡಿ, ಇದು ರಾಂಗ್ ಇದೆ. And this is program relative address means program counter X plus program counter address will give you relative. Auto increment is nothing but what? Auto increment. So go to the location, access the data. After you access the data, you increment it. Okay, that is what auto increment. It's like a post increment. Okay, so auto decrement means what? Decrement means first decrement it, decrement the data available inside R1 or RI, access it. Before accessing the data, before accessing the data, you just decrement it. Okay, then access the data. First, what you should do, see, auto decrement means access the data. So decrement RI, then it becomes the effective address. Okay, it's very simple. I've given elaborate explanation regarding this with example and all. Now we have stack frame. It's very simple. So what's a stack frame? See, stack frame is very simple. One thing you should remember: stack frame is nothing but subrouting. So I'll call n number of functions. Main will call n number of functions. Okay. So that means what? Main function will call sub functions. Now how the main function and sub functions will be related? Okay, I want to keep track of it. Where to store after sub function is subroutine is executed. I should come back to main function, alva, isn't it? So how I should come back? Using return address. I want to save that return address, right? And even while I'm calling the function, I should send parameters, isn't it? Ala gottidallappa idu actual parameters you have to send. Okay, so I have to keep that data. Okay, that is available using some memory location in the form of the stack frame. That is what here. So these are all parameters you are sending. This is return address. This is FP. So FP is mainly used to access the data, above the FP can access this data using your FP pointer. That means what? Frame pointer. And you can access even this data. Okay, so this explanation of FP is also important, frame pointer. And local variable, parameters, saved or not R1, everything you have to explain. Okay. Okay, shift and rotates. It's quite simple, shift and rotate. Shift ಏನು ಬರುತ್ತೆ, ಎರಡು see, two methods are there. Shift ಅಲ್ಲಿ you have logical shift towards right and left, arithmetic shift towards right and left. Okay, now so 4 will come. When you take rotate means rotate left with count and without count, I think. Yeah, logical shift to left, logical shift right, arithmetic shift ಅಲ್ಲಿ arithmetic shift. Okay, only one arithmetic shift. Arithmetic shift. See, logical shift to arithmetic shift to main difference. Arithmetic shift, what it will happen? So it will, it will take whatever the data you will shift towards right side. That will be, added. Okay, added to the same. See, it is added to the same operand. If I shift towards, suppose here 0, I shift towards right side means this 0 will be command, this 0 will go to the, carry location. Along with that, the 0 will move towards left. Okay, so like that. Yeah, arithmetic shift is nothing but your sign bit, right? Sign bit. If 1 is here, everything will be 1 1 1. Alvapa. So this will be sign bit shifting. Then rotate is there. Rotate with carry, without carry. Okay, rotate left with carry, without carry. Okay, one example you can give. That's more than enough. And okay, finally, I'll tell you. See, arithmetically, what is it? Shiftingly, logical shift to arithmetic shift. When comes to rotation, rotation with carry, without carry. Okay, so rotation with carry, without carry. So you have to explain all this concept with one diagram. You can take one instruction you take, and you have to explain. At least diagrammatically you represent it. Not required explanation. Diagrammatically you represent it. That may be enough. And we'll go to seventh one. Just see the question here. Seventh was, just simple. It is, effective address. I want the effective address. Okay. So for this also we have given an explanation. Effective address means what, isn't it? So if you take 20 of R1, R5 means what is the effective address of this first operand? So 20. Okay, this is what index with uh, of index mode of addressing. Okay, 20 plus content of R1 will give you the address of first operand. 20 plus 1200. You add both, you will get 1220. Go to 1220, whatever the content is there, that is what your first operand. That is what the effective address. Effective address means what? It will give you the information of the address, location of your data, where it exists. Okay. So here, second one is here no required any effective address because data itself is available here. Okay, that's about second one. Third one is here R5. So go to R5, you will get the data directly. So effective address is directly R5. You go to R5, you will get the data. Then here it is again indirect mode. So don't go, if you go to R2, you never get the data. Go to R2, there is some address is there. That address will give you the information of where your data exists. So even it is auto decrement it is. So go to R2, we have 4600 minus 18, you will get 45999. Go to 45999, there you will get the data. That's what effective address. Even here also. R1 means you never get data in R1. Go to R1, there is you have 1200. In 1200 you have the data. Okay, that is what effective address is equal to 1200. It will give you the address. And walk up 1200. Go to a home number 1200. You have the person there is your operand. It indicates like that. If you go to 7th B, write any diagram, describe the input and output operations. Am I fast? Okay, it is. Yes or no? Okay, no. Is it okay? Because within 11:10, I want to cover all questions. Small revision, that is why. Okay, no? Is it okay? Okay, no? I can. Only one student. Yeah. Okay, right? I can. Even if I drag the same question for, more than 5 to 10 minutes, you will also get bored, isn't it? So, because you're already studied, you're already written in the assignment book, let me cover. Okay. Uh, Fine. We'll complete it anyway. That's what my target. And even, what happens, some students may be uh, absent in that particular day. They will recall the explanation right now. That's what my main intention, nothing else. Anyway, I'll take seventh B. Seventh B. Okay. Okay. Seventh B. It is input and output operations. You have to explain one simple diagram here. Okay. So this diagram, it's very simple. You're already aware of it, I felt. You should take, this is input device, this is output device, this is your input device, this is your output device, this is the processor. Okay. So all are connected to a bus. Okay. So now what I will do, suppose the keyboard want to send some data, means what I should do, I should enter some A, some alphabet. Okay, so as soon as I entered some data A into the alphabet, so the processor should know, right? Okay, some data is available inside the keyboard, isn't it? So how it knows? By enabling one bit here. SI in bit will be enabled. Okay, so what will happen? Sin. Okay, the sign bit will be enabled by 1. Before it was 0. Now I will make that flag bit as 1, so that it indicates some data is read by available by the in the keyboard. That means what, user has entered some character, and that character is stored where? In the data in. Here, data in. Okay, so that can be read by the processor now. Sometimes what happens, even the processor wants to send some data or display some data on the output screen via output devices. At that time, what this will do, it will send the data. Okay, I want to print some data on the keyboard, on the, sorry, monitor. So what it will do, it will give some A will be sent here. Okay, to the printer, not printer, monitor. Now that data will be available in data out register. Okay, so when the data out register is having the data A, now S out bit will be enabled by 1. Instead it was 0. Okay, it was 0. Now it has been changed to 1. So that what will happen? The display device will display the A. As soon as it is displayed the data, by default S out becomes 0 again. That's what you have to explain, that input output operations. Okay, that's about your seventh B. If you go to eighth, it's very simple. What is saving address? See, I can store the written address any, even in processor register also I can keep, even in memory location also I can keep, even in stack also I can keep. Okay, so I think I've given the neat answer for this question, I think, right? Okay, you can keep, how to keep the data in stack by pushing the data. Okay, so the memory location we can keep the data, and even processor register also you can keep the data. All are possible. Okay, if you go to 8B is what question? Let me see once. Uh, Three difference between stack and queues. Very simple, Allah. Very simple. So in stack you have push and pop operation. Queue you don't have push and pop operation. This is last in first out. That is first in first out. Uh, Here you require top is equal to -1, only one variable. There you require rear and front. Okay, so like that you can differentiate between stack and queue. Then program mapped input output, and memory mapped input output. See, here only I'll explain. I'll show that what she has written. Let me see. Yeah, program control means what? See, here what will happen? Your data is available here inside the data in and data out. Okay, so inside the keyboard only I have the data. Inside the the display unit only I have the register. I can keep in register the data. I will keep it in some register, and I can transmit between processor and input and output devices. That's what program controlled. Okay, Memory mapped means what? Even your data in this data, if it is very large, only one character andre okay. If I am sending some bulk amount of data, what happens? I want to keep it in some large space. Where I'll get large space? Obviously, it is in memory. So what I will do? I will keep in the inside this data in. I'll keep some address. Okay, now which address? Memory location address. So go to that memory location address. From there, you access the data. So what happens? You are going to use the memory space also to do, the 1 second. She is asking one question. Yeah, I'll come to you, Pa. 1 second, I'll come to you. When data in will be there, so obviously we can take the data from the memory also. We can keep the data even in the memory also. Okay. So like that, even I can keep it in the memory also sometimes. Okay. Not only in registers, we can use the memory space also. That is the main intention. Hope you are clear. That is about memory mapped. In memory mapped, memory will also incorporated between processor, input device, output device. But here in processor mapped, not required memory, only between processor, input device, and output device, with the help of only registers. Which registers? Data in and data out. In memory mapped, you may use the space of memory. Okay, I think one girl asked what question? Janu has given one question. Which of these possibilities support the subroutine nesting and which support subroutine recursion? See, when we take the recursion, what is the meaning of recursion? Recursion means internally we can store the, internally we can call n number of times the same function. Alva. See, best example is actually subroutine recursion. It's there actually. We have not considered much actually. But in subroutine recursion, we required stack probably. We require the stack. Okay, we required 100% stack to do the subroutine recursion maximum. Okay, uh, usually recursion means what? One function will call the same function again one function will call same function again. Okay, now so by that time, you see the question, which of the possibilities support subroutine nesting will be support? Okay, probably it will recursion will take even okay, stack is the, but they provided even memory location also. Even while you are uh, see, one thing is very, very important. We can use stack even for nesting and for subroutine recursion both. Okay. Processor register and memory locations, they're like, uh, even you keep inside the stack also, we required memory location. We required registers. Okay, with the help of registers, with the help of memory locations also, you are able to store your recursion data and your nesting data. You can keep actually, you can use even memory also, processor also, but maximum we required stack. Maximum we required stack. Stack is the best actually for both subroutine nesting and subroutine recursion. ಜಾನ್ವಿ ಕೇಳಿಸ್ತಿದ್ಯಾ? ನಾನು ಹೇಳಿದ ಅರ್ಥ ಆಯ್ತಾ? Understood, Janvi? Actually, stack is the best, okay, uh, use it for both subroutine nesting and subroutine recursion. Particularly recursion, though, we required 100% stack. Okay, but we can't neglect processor register and memory locations, because you can to create a stack we require memory only, isn't it? Are you agree? Okay, and sometimes we require, while you are using the subroutine and all, we may require some registers also, processor registers, isn't it? That's why we are incorporated, all are possible. Okay, but if I say uh, maximum 100% accurately which required is stack is the main thing we require. Anyway, we can consider all are required for subroutine resting also and for subroutine recursion also. Any query? Janvi, got it? Okay. Nothing else, nothing to worry. But while writing also you can write it. What you write for recursion, we require the stack. You write it here on the stack in front of the stack. You write it very clearly. So the requirement of stack for the subroutine nesting and subroutine recursion is required as the recursion called again and again. So we required stack frame to store the return address, parameters, and local variables. That is why on stack, the stack will support both subroutine nesting and subroutine recursion. Even in front of memory location register also you can write it. Okay, registers will hold the uh, data of local variables and global variables and all. So I can use. Okay, even memory location also I can include. Subroutine linkage is very simple. Subroutine linkage is same thing, whatever I already explained. So subroutine is linkage is nothing but we record one link register, right? Extra thing is link register. I think this is the diagram. Yeah. So when I call subroutines here, I'll call subroutine. What will happen? So next instruction, suppose 2000 is the current instruction. So next instruction is 2004. I'm supposed to execute 2004 now. After 2000 will be completed, I'm supposed to go for 2004, 204, sorry, 204. But what will happen? I will call the subroutine. This subroutine is available in 1000 location. I'm jumping now. I'm jumping to 1000 location instead of 204. So anyway, after my subroutine executed, I should come back to 2000, 204. So where I should keep the 204? I have to keep the 204 somewhere. Where? In the linkage register, LL. Okay, that is what I have done here. In the link, what I will do, 204, I'll store it here. Okay, then for PC, I load 2000 because PC will now, the address of 1000. Why? Because next instruction is, 1000 it is. So obviously, my PC should hold 1000, not 204. That is why I will take the 204 from PC and copy to link register. For PC, I will load 1000. Okay. Now anyway, 204 is available in my link register. After subroutine will be executed, I'll come back. Well, I'll come back. What is my PC should become? My PC should become by 204 now. So what I'll do, I'll take the data from linkage register to my PC. A step. Very simple. Okay, something like that. So I have a I have a bag with me, so I can hold only. I have what example I could give, practical example. Uh, mm, so you have some account in SBI Bank. Okay, so SBI Bank you have an account, and even Vijay Bank also you have some account. Okay, so what I'll do, you have a amount of 1 lakh in SBI account. Okay, not 1 lakh. Some 5 lakh you have in SBI account. So what you should do? So some people will okay. I'll okay only 2 lakh. Okay, you have 2 lakh in SBI account. Okay, and in Vijay Bank you don't have any amount. What you will do? If somebody will ask, give me the account, give me the amount of 2 lakh. What you will do? So if at a time I can't send complete 2 lakh to one particular person, what I'll do? 1 lakh I'll send to my Vijay Bank account. 1 lakh I'll keep it in SBI only. Later, I will send uh, this 2 lakh amount, 1 lakh from Vijay Bank to that person, 1 lakh from State SBI to that particular account. Okay, like that. I'll keep track. Okay, first to PC 204, 204, I'll copy in link register. So next from link register, I'll receive back. Okay, the PC will receive back. Why he will receive back? Because initially you will require 1000 for subroutine instructions to be executed. So we will execute all the instructions of the subroutine with the starting address 1000. After completed, he will come back. He'll come back to 204. But where is 204? It's available in my link register. So he will reload it. Okay. That's all. It's very simple. So what's the next question? Okay, this one, right? And here you have to explain one multiplication. Okay, multiplication you have to explain. Okay, that you have to do it. Okay, so let's see the program. Okay, so this is the program. You're supposed to write the program. Okay, move into R1. Okay, call subroutine. But subroutine program illa illi. She has to include a subroutine program also. Okay, subroutine baratta. You have to include. Okay, one program you have to write. ನಾನು ಕೊಟ್ಟಿದ್ದೇನಲ್ಲ, I've given the program. Okay, write the same thing over there. Then interrupt hardware. So how the interrupt will do. So interrupt means what? While I'm executing some instruction. Suppose executing 10th instruction. What happens after 10th instruction I've executed? I want to call some printer. I want to call some, you know, keyboard input device I used to call. Okay, that time I should go from here to here. I'll just move. That's what interrupting. While I'm executing, see, interrupt me means what? I'll give best example. I'm teaching here. Right now, I got one call. Okay, so what I did, I've interrupted. Somebody has interrupted me. I just, uh, muted here and spoken in mobile, and I come back. Hope you are clear. Okay, so while I'm teaching you, that's what my work. Somebody has interrupted, some call, mobile call, somebody has called me. So I just off the speaker, mute it, and I went there and I've spoken with them. I came back. Okay, the same thing. So during that instructions are executing here, one by one instruction, one, two, three, four, five, like that. In between, somebody will something. Suppose I want to read some data, suppose I want to write some data, then I'll go to that. Reading means go to keyboard, writing means monitor. Okay, so that's what interrupting. Okay, so that's about you have to explain what is the hardware vector. Vector interrupt is very simple. Vector interrupt is what, nesting is what, simulation request is what, interrupt service routine, latency, disabling, polling. Okay, so everything you have to include here in the explanation. This is hardware. Um, so so usually vectored means what? So the devices will be they're in some order they used to keep. Okay, so when the device 1 will interrupt, device 2 will interrupt, device 3 will interrupt. Okay, so see, it is opposite to polling. Polling means what? Polling is nothing but what? Polling is nothing but the processor will come to each and everybody's device and it will ask, you want my service, you want my service, like that. But in vector, what will happen? The device will request the processor. Okay, so device 2 will request, device n will request, whichever the service processor will request, it will provide the service. That's about processor. Okay. Interrupt nesting. So what will happen? All the device 1, device 2, device 3 will be grouped together. So based on priority, they will group it together, priority wise. Okay, now if I go to that group means all the devices inside that group will execute. Later I'll go to second group, later I'll go to third group. Okay, so priority wise I'm going to make the group. Okay, group of devices. So next we have dicey chain. Dicey chain means what? Whichever is nearer. So device 1 is nearer to processor means device 1 will be served first. Next device 2, next device 3, like that. Okay. Next is priority group. Okay, this is priority group wise. Service routine means what? Very simple. What is service routine? So interrupt service routine means you have to write the diagram. So while calling the routine will execute and it will come back to main. That's what interrupt service routine. Latency means what? See, I will call. I'll give you this diagram explanation. See here. See here interrupt. I'll call here. Otherwise I'll take. See here. See this device will interrupt. I want the service of processor. It requests the service, but processor will give the service after 2 milliseconds. The delay is there, no, that is known as interrupt latency. Okay, I will request now, but I will get the service after 2 milliseconds. Maybe processor is busy. Okay, so by that time you have to wait. So the duration in between your requested and you are getting service, the delay is known as interrupt latency. Okay, last thing is, I think by this 11th is simple. What is PC? What is address bus, data bus, control bus? Control bus means control instruction, read or write or like that. Data bus means data, what content you want to transmit via the bus. That is data bus. Address means what address you are going to send. That's what address bus. We use the address bus to send address. We use data bus to send data. We used to use control bus to send control signals. That's all. PC I already explained. General purpose registers already explained. And here also, so word alignment. So word alignment also I told you. If your processor will, uh, let me tell you what is, yeah. Suppose you can store, see how many here? One space means 1 byte, second space 2 byte, third space totally 3 byte, fourth space 4 byte. So 4 byte is 4 byte or 4 locations you can use. Okay, to store complete 1 word of data. That means what? 1 word is equal to 4 into 8. 4 into 8 means 32 bits of data. Okay, 32 bits of data. 32 bit is equal to 1 word, or 1 word is equal to 4 byte. Okay, so then your system is 32-bit data. 32-bit system. 64-bit means 8, right? 64-bit means one word is equal to 8, 8 byte. Okay, so like that, you have to give the information. Suppose only two locations are there here. Okay, so only you can in one here you can one word is equal to only 16 bit means 2 byte. One word is equal to 2 byte. Okay, so like that you have to give. And we have last question is there, that is assembly program. So assembly program to read a line of character and display it. Okay, and assemble directives. It's very simple. You should write the program. So I want to read some data. So while reading some data, you have to check the bit, which bit, the in status bit. So in the third location, if that bit is 1, it indicates you have the data, you can read it. Otherwise, wait. And here also writing means what? Echo, display the data. So if this go to third bit location and check the status. If that is equal to 1 means you have the data, otherwise you have to wait. Branch is equal to 0 means you have to wait, otherwise you have to display the data. Okay, so that's what's very simple. And you're comparing CR. Carriage written is nothing but it indicates your data is slash n. If slash n indicates that it's last character, you have read the last character. See, whenever I read string, suppose my computer organization, by default after organization last character is slash n, isn't it? It is ended by slash n. So that indicates that slash n indicates that it's a carriage written data. It indicates that you have read the complete data. All the data in the keyboard I have read completely. That indicates by last slash n. Okay, that is what your CR indicates. Okay, and we have last one, that is assembler directives. See, assembler directives are, they won't do any operation. While you write the instruction add a comma b means you are adding a and b. That's an operation performing by processor. But here some instructions are giving the directions. They are giving the directions to the processor. That's all. That is why they are known as assembler directives. Okay, so here equate means you just equate 200 to the variable. That's all. Origin means you should start the memory by your data will be start with a location of 204 address. Data byte, data byte means what? It indicates your data is of type byte. Data word means it's of type word. Then reserve, you are going to reserve some bytes of data. Okay, that's what reserve. Reserve 400 means reserve 400 bytes of data. End means your instructions will be ended. ಓಕೆ ಎಂಡ್ ಪ್ರೋಗ್ರಾಮ್ ಈವನ್ ಗ್ರೂಪ್. ಸಿ ನೀವೆಲ್ಲ ಏನೋ ಬೇರೆ ಬರ್ತಿದ್ದೀರಾ ಕಂಟೆಂಟ್ ಇಲ್ಲಿ. ಆಕ್ಚುಲಿ ನಾನು ಕೊಟ್ಟಿದ್ದು ಕಂಟೆಂಟೇ ಬೇರೆ. ಇದು ನೋಟ್ಸ್ ಈ ತರ ಇದೆಯಾ? ಆಕ್ಚುಲಿ ದಿಸ್ ಇಸ್ ದಿಸ್ ದ ಸೇಮ್ ಆನ್ಸರ್ ಇನ್ ದ ನೋಟ್ಸಾ? ಆಕ್ಚುಲಿ ಇನ್ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಇಟ್ ವಾಸ್ ಕ್ವೈಟ್ ಡಿಫರೆಂಟ್ ಆಕ್ಚುಲಿ. ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಅಲ್ಲಿ ಫಸ್ಟ್ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ಸ್ ಬರೀಬೇಕು. ಶುಡ್ ರೈಟ್ ದ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ಸ್, ದೆನ್ ಯು ಹ್ಯಾವ್ ಟು ಎಕ್ಸ್ಪ್ಲೈನ್. ಆಕ್ಚುಲಿ ಯು ಆರ್ ಗೆಟಿಂಗ್ ಮೈ ವರ್ಡ್ಸ್? Everybody has written the same answer. See the textbook once, okay? For this last 12th B question, see the textbook once. Okay, let me take the attendance. Any doubts you have, just pose a question over here. Asta? Asta? Asta is there? Is not there? Asta. Yeah, submitted Asta assignment. Huh? Submitted in mail ID? Mail no or class work? Sorry, Google Classroom. Okay. See, and one more thing, I just want to inform you. I found out some people are giving the same copy. Some student who has written, they have duplicated. Just they erased the name of the student and they are giving. Please don't do all these things. Okay. If you do this, do the things, 100% you will be caught. Okay. So I request, not request, I mean giving one, you know, uh, last word. This is the last word. Please don't do such kind of things. The students already sent duplicate copy. Please resend your own copy. Still you have time. If you are not given the your own handwritten copy by yourself, see the consequence later. Okay? Hope you are getting my words. The last word. Whoever sent the same copy to me, please resend the new copy. We are not smarter than you people, but we are experienced. 11 years of teaching. We can make out how the students are. Simple common sense, so even we have. The people may duplicate the same assignment and they can resend it by changing the name. We have such a simple common sense. We will verify it. We can make out. 100% we can make out. Okay, I don't want to tell the names. I don't want to tell the names in front of every other students. Okay, even I don't want actually. By hurry bari you may send, but you have still time. Resend. Take your own book, write it in the book and send me the copy. If it is not the case, see the consequence later. I am the faculty here to give the assignment marks to you, isn't it? I'm here, no, to give you the assignment marks by me only. Then I should be a person who is agreed, yes, it is your assignment, then I can give you the marks. Don't ask me later, why ma'am not given the assignment marks. I'll speak at that time. Okay, so this is my last word. Please take it seriously and give the assignment of your own handwriting and yours copy. If that is not the thing, see the consequence. It was very serious. You people are very smarter, we can make out. But even we are experienced. We know the students, how they are. I hope who are those students who send the same copy. It's up to you. I don't want to disclose the name of the students. I'll wait. I've already taken the PDF copies and I've kept separate. Their name also I've kept separately. It's very simple. It's very easy. I can distribute it to each and every faculty in the department. Throughout your semesters, you're in third semester right now. Third, fourth, fifth, sixth, seventh, eighth. Throughout all the semester, your name will be, highlighted. This is the student who has done the, malpractice. It's up to you. You want me to disclose your name? Or you will resend me the different copy. It's up to you. I don't want to repeat the same thing. While I'm giving the assignment marks, see and one more thing, I never evaluate your marks. See the internals marks. I'll keep it 0. You ask me at that time, ma'am, why ma'am? You have given 0 marks. I will give you with proof. Hope you have understood what I'm telling. If I never get this different copy, your own handwriting copy, internals marks will be 0, totally 0. You will ask no at that time, why 0? I will give you the answer at that time. Very clear answer I'll give you. Okay, Asta, you have sent it, no? Abhijit, Yusuf Khan, present?
Yes, ma'am, present.
Oh, Abhijit Kumar. Okay, mailed Abhijit. Okay. Abhishek Barnwal. Abhishek. Okay, I think Abhishek is absent. Abhishek Mishra. Abhishek mailed. Okay, Abhishek. Okay, done. Abhishek Mishra over. Abhishek Mishra attendance. Abhishek Mishra. Abhishek Mishra is absent. Okay.
Present, ma'am.
Okay. Okay. Adish. Adish. Okay, Adish. Aditya. Aditya present. Okay, Aditya. Aditya Agarwal mailed. Okay. Okay, mailed. Okay, fine. Aditya Raj. Aditya Raj. Okay. Akanksha. Akanksha. Akili Chakravardan. Akili Chakravardan.
Present, ma'am.
Mailed, Akili
Present, ma'am.
Chakravardan. ಅಲ್ಲ ಮೇಲ್ ಮಾಡಿದ್ರ
Yes, ma'am. Mail.
ಓಕೆ
Yes, ma'am.
ಓಕೆ ಓಕೆ ಅಕ್ಷತ್ 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 I think Akshat is absent. Yeah, okay, Akshat. Amog. Amog. Okay. Anaga. 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 Anagashri. Anagashri. Okay, Anagashri present. Okay. Okay, Anagashri. Amog is not sent, no? Amog is absent also and he has not given. Hey, Amog, yes, Bharadwaj. You assignment kotra? Amog, yes. 13 user number. Have you mailed or not yet? Huh? Okay, mailed. Oh, okay, Ananya. Ananya. Okay. Okay. Shivani. Okay. Ankit Kumar. Ankit Kumar. Okay. Okay, Ankit. Ankita Niranjan. Okay. Anusha. Anusha. Okay. Anusha mailed. Okay. Apurva. Okay. Apurva M. GS present Apurva M mail. Okay. Aryan. Aryan mailed. Okay. Azim Hussain. Okay. Vanupriya. Okay. Bhargav. Bhargav Reddy. Bhargav Reddy. No reply. I think he's absent. Sri Harsha. Sri Harsha. Sri Harsha is also absent and is not giving any answer also. Rishita. Rishita Reddy. Rishita is there. Rishita is not there. Yeah, okay, Rishita. Okay, present. Rakshit. Rakshit. Okay. Chandan. Okay. Chandrakant. Chandrakant. Okay. Chetana. Okay. Have you mailed Chetana? Assignment? Huh? Mail ಮಾಡಿದಿರಾ or you yet to mail? Have you mailed? Chetana 32 user number? Yes, ma'am, I text. Okay, okay, fine. In mail, no? We mailed, I think. Okay. Chirag? Chirag, okay. Chirantan? Chirantan, okay. Chitra? Okay. Sai Sankirtana? Uh, okay, fine. Darshan? Deepa? Okay. Deepali? Okay. Sai Vasantareddy? I think he's absent. Sai Vasantareddy. ಸರ್ ಬನ್ನಿ ಬನ್ನಿ ಒಂದು ನಿಮಿಷ ಸರ್ ಒಂದೇ ನಿಮಿಷ ಸರ್ ಕೂತ್ಕೊಳ್ಳಿ ಒಂದು ನಿಮಿಷ ಸಾಯಿ ವಸಂತ ರೆಡ್ಡಿ ಐ ಥಿಂಕ್ ಈಸ್ ಆಬ್ಸೆಂಟ್ ಹರ್ಷ ಓಕೆ ಹರ್ಷ ಪ್ರೆಸೆಂಟ್ ಫೆಬಿಯನ್ 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 ಈಸ್ ಆಬ್ಸೆಂಟ್ ಸರ್ ಕೂತ್ಕೊಳ್ಳಿ ಸರ್ ಒಂದು ನಿಮಿಷ ಫೆಬಿಯನ್ ಈಸ್ ಆಬ್ಸೆಂಟಾ ಸುಚಿತಾ 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 ತುಷಾರ್ ತುಷಾರ್
Present, ma'am. Actually, the classroom link was not working, so I sent it to the mail. That's fine, right?
ಓಕೆ ತುಷಾರ್ ಫೈನ್
Okay.
ಗಗನಶ್ರೀ ಓಕೆ ಓಕೆ ಗಗನಶ್ರೀ ತುಷಾರ್ Ganesh. Ganesh. Okay. Ganesh mailed. What is your assignment status? Have you mailed or not yet? Classroom. Gaurav? Gaurav? Okay. Sudhir? Sudhir? I think Sudhir is Pranati? Pranati, present. Okay. Guru Darshan? Guru Darshan, present. Okay, made. Okay. Vishwajit? Vishwajit, okay. Harish Kumar? Harish Kumar D. Harish is not there? Harish Kumar D. Harish Kumar is absent. Okay. Harishwini, present. Harsha V. Harshvi. Okay. Harshit. Okay, mailed. Okay. Hemant. Okay. Ishan. Ishan, what about your assignment? Okay. Let me wait one more time. Ishita. Ishita. Ishita, present. Google Classroom. Okay. Manasa. Jayam. Okay. Jayam. I sent in. Okay. Mail. Okay. Jeevan Raju. Jeevan. Okay. Yeah, I got it, Jeevan. Jannavi. Yeah, I got it. Anish. Anish Shetty. Anish Shetty. Bhuvanesh. Bhuvanesh. Bhuvanesh is absent. Kamal Nayan. Kamal. Okay. Karthik. Okay. Karthik mailed. Kavya. Kavya J. Okay, present. Kaza Mainuddin. Why is absent? Kushi. Okay. Pranav. Pranav. Kritik. Kritik. Kritik is absent. Lata Shekhar. Okay. Lavanya. Lavanya. Madhusudan. Lavanya is absent. Okay. Madhusudan. Okay, present and mailed. Okay. Mahesh Yadav. Okay, Mahesh. Maithili Joshi. Okay. Mamisha. Okay. Manik. Manik Chauhan. Okay. Mahesh. Manjesh Gowda. Oh, Lavanya present. Okay, Lavanya are present. Manik also present. Manjesh Gowda present. Manjesh is present now. Manjesh, one more time. Manjesh present. Okay, Manjesh. Done. Sahil present. Medini, right. Yeah, okay, Medini present. Mohammed Saif. Mohammed Saif. Saif is absent. Mohan. Mohan. Mohan M. And even Medini, your assignment. What about your assignment, Medini? Submitted, Mailed, okay. Mohammed Saif to absent only. Okay. Mohan M. Mohan. Mohan is absent. Monish. What about Monish? Absent. Mohammed Zidan. Okay. Okay. Muskan. Muskan. Okay. Assignment. What about assignment, Muskan? Mailed. Okay. I'll see to it. Nagendra. 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 I think is absent. Natua Shruti. Natua Shruti. Present. Naveen Kumar. Naveen. Naveen is absent. Okay. Thank you. Thank you, one and all. So I've revised it. Okay.